Welcome everyone. Today we're going to talk about exponential limits at infinity. We have a limit, and the limit is limit of 1 plus 1 over n to the power of n as n approaches to infinity is equal to e. We're not going to evaluate this limit in this video, but we will do that in the future. For now, we just need to know that this limit is equal to e, and by this we will have to evaluate the following limits. Limit of 1 plus 1 over n to the power of 5n as an approach to infinity. I always want to see this form when I am evaluating the limits, so I need to write this as 1 plus 1 over n to the n, and this will be to the power of 5, right? Therefore, since this is e, and when I plug in, I know this limit is e, so I'm going to get e to the fifth power as my answer. It's this simple. It's a really simple topic. Let's just see some examples, and that will be it for this topic. Limit of 1 plus 4 over n to the power of 5n as an approach to infinity. What I'm going to do for this is, as we said, we always want to see 1 plus 1 over n to the power of n form. And we don't have that here. So I need to say something to this n, so these four, so I can save myself from this 4. I'm going to say n is equal to 4t. The reason I do this change is so these 4 will cancel out. I'm gonna be working with t, only 1. So n approaches to infinity. This is gonna tell me that 4t approaches to infinity, and therefore I can say t approaches to infinity. So I can write this as limit of 1 plus 4 over 4t and 5 times 4t, right? So I'm gonna get, what do I get from here? Is 1 plus 1 over t to the power of 20t, right? And if I take this one step forward, I mean, from now on, it's not really, we don't really need to take it to this step, but let's do it one more time. T, and this is to the power of 20. And since I know this part is e, I'm just going to say the answer is e to the power of 20. Yeah, it's really this simple. Last example, at my power, I have 2n minus 5. That's the only difference. So I want to save myself from this 3, right? Again, I'm going to say n is equal to 3t. And my t will be approaching to infinity again. So what I'm going to do is limit t approaches to infinity. 1 plus 3 over 3t. And let's see, what do I get? 6t minus 5, right? So do we have enough space for this? Yes, we definitely do. I want to clean this part though. All right, good. Limit our t approaches to infinity, and 1 plus 1 over t to the power of 6t minus 5. Okay, everything looks good, but the issue is there's a minus 5 here, right? So I need to separate this from 6t minus 6t so I can get the form that I'm trying to get, right? It took some time for me to figure out what I wanted to say. It happens to best of us. This is going to be 1 plus 1 over t, like this, right? So this part is clearly e to the 6th power. This part is, there's a 0 here, since when I plug in 1 over t, when t approaches to infinity is 0. We know this, we learned this. So from here, I'm getting 1. E to the 6th power multiplied by 1 is clearly e to the 6th power, so this is going to be my answer. And my last rule is, it has the same idea, but it can help us to figure out limits faster, so let's learn it. Limit of 1 plus a over bx plus c to the power of dx plus e as x approaches to infinity is going to be e to the power of a times d over b, right? So this is what we are working with. And I need to say that to use these limits, I need to be working with 1 over infinity form. And clearly, since my denominator is growing way faster here, this part is 0, and this part is going to be infinity, right? So I am working with e over 1 over infinity. Therefore, I can say this is true. Let's see some examples. Limit of 1 plus 2x plus 3 over 3x minus 5 to the power of 2x plus 11 as x approaches to infinity. I am writing the examples completely random, so the numbers can be really weird, but it's okay. Oh yeah, this is not what I was working with, right? 2 here. Okay. So I need to work with 1 over infinity. Let's see what I'm working with. From here, I am getting 0 in this limit, and from here, I'm getting infinity. So yes, I am working with 1 over infinity, right? Therefore, I'm going to use a formula. Well, the limit I learned. My a is equal to 2, my d is also equal to 2, and this is over 3, therefore my b is 3. I'm going to get e to the power of 4 over 3. Let's do another example. Limit of when my x approaches to infinity again. Let's change how the limit looks a little bit so we learn new things, right? When it's not a hard topic, of course, but okay. Now inside, I am seeing when I try to plug it in, I'm getting 1 over 1 to the power of infinity again. But the form is different. It's not this form, right? So I need to transform this into this form. How am I gonna do that? I'm gonna do polynomial division. Let's divide these two terms we have. Let's divide, and I'm going to, from, is it 10? Yes, it is 10. Therefore, I can write this limit as 1 plus 10 over 3x minus 5 to the power of tx plus 11. And now I'm working with the form I want to. I can say e to the power of a times d times, or a times d over b. And my a is 10, my d is 2, and this is over 3. Yeah, the numbers are really weird looking, but it's okay, it doesn't matter. And let's do one more example. Last example. There's no point of making this video longer, so 3x plus 5, right? And as usual, I need to check if what am I working with. So when I plug this in, I am seeing I am getting 2 over 3, and this is to the power of infinity, right? So I am not working with 1 to the power of infinity this time. Therefore, I cannot use the limit I learned today. Therefore, I'm going to just look at this 2 over 3 to the power of infinity, which is clearly 0. And that's going to be it.